Anyone who has clicked on this video probably already knows that the Euler-Lagrange equation is typically derived using a protuberance argument, and that the equation itself has a very close relationship with geodesics. In this video, I plan to derive the Euler-Lagrange equation by exploiting this close relationship with geodesics. Mortal Kombat Master Shao Kahn should be able to assist me if needed. Now we know that a geodesic in flat space is typically written as some form of dy over dx equals a constant. But a geodesic in flat space can also be written as d dy of ds dx equals d dx of ds dy. This equation, while much uglier, can be thought of as for each tiny piece of arc length, ds, the excess portion of ds over its horizontal displacement, dx, shifted vertically, is equivalent to the excess portion of ds over its vertical displacement, dy, shifted horizontally. In this picture, we see that the horizontal displacement in red, shifted vertically in orange, shrinks by the same amount as the vertical displacement in pink, shifted horizontally in purple. In other words, you can think of the equation as a staircase, where the height of the next step is equal to the length of the current step, and the pattern repeats. This equality is what keeps the path from bending to the left or the right as you move across it, which is a primary property of geodesics. Now, if all of a sudden we're dealing with a space that's not flat anymore, like this multicolored but mostly orange grid in the picture here, floating above the flat blue grid, the equation d dy of ds dx equals d dx of ds dy no longer holds, because the dx at one place may be different than the dx at another. The same could be said of the dy at one place. In this picture, the chances that this equation still holds are not good, because the dx's and dy's are now allowed to vary so much. But we can adjust the equation to make it not bend to the left or right after changing the space. We can do modifications to ds dy in the equation so that it is more of an apples-to-apples comparison with ds dx. Let's say we have two dx's of different length, like in triangles 1 and 2 at the top of the picture here. If we enlarge triangle 1 so that the dx of triangle 1 now matches the dx of triangle 2, the ds and dy of triangle 1 will also be proportionately enlarged. Now we can compare an enlarged version of triangle 1 with triangle 2, and we have an apples-to-apples comparison. Now, how do we quantify the enlargement we did of triangle 1? Well, however much dx changed, ds and dy changed by the same amount. So ds becomes d dx of ds, and dy becomes d dx of dy. So, after all of that, we can draw the conclusion that d dy of ds dx equals d dx of ds dy, being a geodesic in flat space, must be modified into d dy of ds dx equals d dx of d dx of ds over d dx of dy to become the geodesic or warped space. Next, we do some notational massaging. I hope it's not the thing that throws my derivation off, because it sure lines up beautifully with the next step. If we let L equal ds dx, then the equation becomes d dy of L equals d dx of dl over d dy dx, which is the Euler-Lagrange equation when s is equal to the antiderivative of L in terms of x. To sum up, I really only used 2 steps to derive the Euler-Lagrange equation, which may be some sort of record. First, I defined a straight line in flat space as d dy of ds dx equals d dx of ds dy, then adjusted it so that any changes in dx are accounted for in the rest of the equation. That's it. I wasn't really going for speed here though, I was going more for clarity, and I'm not sure I achieved it. Most of what I strive for in my mathematical work is to make difficult things easier to comprehend, and more intuitive when I can, since I already trust the formal proofs and I don't need their sense of rigor. I think a true search for truth should consist of appeals to logical rigor, experimentation, and impersonations. No, Roller Gator, intuition. Yes, those three: logic, experimentation, and intuition. Super tough to argue against anything that appeals to all three of these things. Well, I guess if nobody finds anything wrong with it, this derivation is a bittersweet victory. I wish I could say I cleaned up the relationships between the Euler-Lagrange equation and geodesics, like former IWGP champion, the cleaner Kenny Omega, cleaned up New Japan Pro Wrestling, but I feel like I'm still pretty far from that. In any case, I feel like celebrating, so Shao Kahn and I are going to audition for a Sgt. Pepper's Lonely Hearts Club Band tribute band. Or maybe I'll sleep all day and run all night playing the 1986 board game Fireball Island with Eddie Raven and the ghost of Eddie Raven.